Hey everyone, welcome to Tutoring. Hope you're feeling great today and feeling refreshed because this question that we're doing in this video is going to be intense. So it's going to be on partial fractions. If you haven't checked out the topic video or the other tutorial videos on partial fraction, make sure you check that out before you come here because we are going to implement a lot of the things we've learned in the other videos. Right, so let's get into the question because this is going to be a long one. So strap yourself up and let's have a go. Part D. We have to anti-derive this function right here. This is a definite integral, so we'll also have to sub in 0 and -12 at the end. The first thing you should realize about this function is that there are two factors on the denominator. If there are two factors, the first thing that comes to mind is partial fraction, right? So partial fraction, we need to know that we have to split this fraction into partial fractions. And before that, there are three types of partial fraction. There is the linear factors, there is the repeated linear factors, and then there's the irreducible factors. If you have a look over here, there is a linear factor, but the thing is the other factor is irreducible. How do we know if it's irreducible? Well, if you find the discriminant of this x squared plus x plus 1, that is b squared minus 4ac. So b squared is 1 squared, so the coefficient from x is 1, minus 4 times the coefficient in front of a and c, which are all 1, and you realize that it is -3, which is a negative number. A negative discriminant means that your quadratic factor is irreducible. You can't convert it into linear factors anymore. So in that case, this is what we apply, the irreducible quadratic factor. How would you convert this into the partial fraction? Well, the formula is over here. A over the linear factor, which is x minus 1 plus bx plus c over the irreducible quadratic factor, which is x squared plus 1, okay? And of course, the goal is to solve for a, b, and c. This is going to be equals to the, our original function over here. I'm just going to rewrite it here, x squared plus x plus 1 times by x minus 1. So let's go into solving a, b, and c first before we can actually start anti-deriving. And if you want to solve for a, we multiply a by x squared plus x plus 1. We multiply bx plus c with x minus 1. We make that equals to 6. Okay, the denominator will cancel out because at the end of the day, what you want to do is you want the left-hand side to have the same common denominator of x minus 1 and x squared plus x plus 1. And the common denominator should be the same as the one on the right hand side. So you can actually start equating, the coefficients, which is to solve for a and b and c. So cancel out the denominator, that's fine, they are the same thing. Let's start doing the simultaneous. Expand it first, ax squared equals to 6. Okay, right, what we can see is this ax squared and then bx squared. If you add them together, so the coefficient a plus b, we don't have an x squared on the right hand side, so a plus b should end up as 0 because we don't have an x squared right on the right hand side. So a plus b equals 0. What we also should see is ax minus bx plus cx, that should be 0. So a plus b, a minus b actually. So a minus b plus c equals to 0. And then the last one, a and minus c. A minus c in this case should be equals to 6. So not 0 anymore, but that's because we have a 6 on the right hand side. Okay, so that's your first equation, second equation, and third equation. Let's have a look on how we should solve for a, b, and c. We've got 3 equations and 3 variables, so definitely simultaneous equation would work. Now, how would we approach this? If you look at all 3 equations, they all have a in common. So why not make a the independent variable? So make b in terms of a. So b equals negative a, c is equals to a. So I bring c over, bring the 6 over, c is a minus 6. After that, I can sub in these 2 new equations into number 2, right? And then make everything in terms of a. I have a, so this second equation right here is a minus b. Minus b would be positive a, right? So it's a plus c, c is a minus 6, and then of course that is equals to 0. So if you were to add them up, we get 3a. I've moved the 6 over, that's 6, so therefore a equals to number 2. which is a good number. Whenever you see a good number, you should be happy, because or else the partial fraction isn't going to look great. But a equals to 2, that's good. Let's solve for b. B is the negative a from here. B is negative a, so b is equals to negative 2. And if you want to solve for c, c equals to a minus 6. 2 is a minus 6, c is equals to negative 4. Right, so if you were to write this on your function, your partial fraction, I'm going to rewrite this one right here, okay? So it's the antidiff 0, negative half up here, and then the partial fraction a over x minus 1, we know a is 2 over x minus 1 plus bx plus c. So b is negative 2, c is negative 4, so that is minus 2x minus 4 over x squared plus x plus 1 dx. So that's the partial fraction from this function, okay? I'm just rewriting this function into its partial fractions. Okay, right, from that point on, you can split the integrand just to make it look nice. 0, negative half, because we're going to antidiff them separately, okay? 2, x minus 1, split that apart, and then you have plus antidiff of 0, negative half. That should not be a minus. So 0, negative half, 2x plus 4, x squared plus x plus 1. I'll actually take the negative out, so in this case this one do become a minus. So my brain was actually thinking far ahead. Right,